attendees joining. We're expecting as much as 90. I'm going to give it just another minute, give people a chance to log on. Okay, let's go ahead and get started. Good morning, CAUS community. I want to welcome you to this almost 3-hour webinar event on pipetting the unexplored aspects. My name is Jason Sarin. I'm the manager of the Lab Equipment Maintenance Core Lab team. Getting started right off the bat, I want to let you know that we have an all-star group of specialists from Eppendorf who are joining us on this call today. We're going to be adding their names, titles, and specialties to the chat box, so you have an opportunity to address questions to them directly if you like. I'd like to give a big thanks to that team for their participation. I also want to thank VWR Avantor for their significant efforts in arranging this. Most notably, big thanks to Tarek Al-Jalal and Salih Kure. Appreciate your efforts. So this is the agenda for today. Babu is going to kick us off with an overview on this complex subject of liquid handling and pipettes. That'll be followed by a presentation by Priya, who's going to talk about proper liquid handling practice and how to minimize the effects of air through pipetting on your research. And then we're going to have a short break, and I will be doing the final presentation where I'm going to teach you how to use the RTEL PCS system using proper technique and also demonstrate user maintenance for your pipettes. Now, the objectives of today's webinar is, number one, to help you understand the intricacies of liquid handling. We want you to walk away here with a clear understanding of pipettes, their modalities, limitations, ergonomics, use, maintenance, etc. Certainly want you to also walk away knowing how to perform your own calibration yourself using the new RTEL system. And then, before we begin, I should warn you that this webinar is recorded, and we're doing this so that you have the availability to come back and rewatch it at a later date, should you want to brush up on some of the content that we'll be presenting. Some housekeeping rules. I'm going to ask that everyone keep their microphones and videos, microphones on mute, videos off. This is so that we can minimize distraction to other participants as well as the presenters. I also invite you to submit any questions you have during any presentation in the chat box. The group of specialists that have joined us from Eppendorf will be there and available to answer your questions during the presentations in the chat box. And time permitting at the end, during the question and answer session, we will give you the opportunity to ask a question, and one of the specialists can then answer that. All right, with that, Mr. Babu is going to kick us off with his presentation. Let me get this set up. Looks like Babu's getting ready. So while he's getting ready for that, let me just introduce him. So Babu is a senior regional marketing manager for Eppendorf. His region is India, Middle East, and Africa, and his specialty is in liquid handling and consumables. Babu, floor is yours.
Okay. Thank you very much for the nice introduction. I hope my slides are visible.
They are, correct.
Yeah. Oh, okay. Good morning, everyone. Very happy to make this presentation and share our knowledge with all of you. Last year, same time in 2019, same time I was in your campus. It's a very lovely and beautiful campus you are all having, and if I got a chance to make a live presentation in front of you, then the things might have different for me. But still, I don't want to miss that opportunity to interact with all of you. So with that note, I will get into my presentation. Eppendorf started in 1945 by two gentlemen called Dr. Nettler and Dr. Haynes. So slowly they progressed, and now they reached no big level in biotechnology instrument supply. So you all know that in 1951 the first pipette invented, and Eppendorf slowly get into that, and we launched our first pipette in 1961. And if I give those pipettes to you, then you will realize what kind of comfort right now all these pipette suppliers may reached in the whether it's a manual pipette or in electronic pipette. So normally when we are looking into the pipette, customers complain that sometimes I'm getting bubbles or residues are staying in the tip, but I'm not getting a reproducible results, or I'm having a lot of difficulty in handling glycerol, methanol, ethanol kind of thing, contamination issues, results are not reproducible kind of thing. Even they say it's quite confusing. It's pipette is a basic tool. If it is not properly chosen, it will have all kind of impact in your day-to-day research. Today from Eppendorf, we are going to make two kind of presentation to address all these issues. One, my presentation, when you are choosing a pipette, how to choose a pipette, what are all the things you need to look into the pipettes. The reason, if you look into our Eppendorf liquid handling, that is pipette catalog, we have more than 7-8 models of pipette, but 80 to 90% of time we get an inquiry only for one part number, research plus pipette. There are other pipettes, and basically these pipettes designed based on the application and the convenience what you can get out of that pipette. My request, when you are choosing a pipette, don't go blindly with whatever available in your lab. I am going to repeat it. Rather, you please contact us, or you can send a mail saying these are all the applications, what kind of pipette I can go, or end of the presentation you will be master in choosing the right pipette for your problems whatever you are having it. Then the second presentation going to be handled by my colleague Priya. She will speak basics of pipetting, what are the different techniques, how to handle a different liquids. So she will handle mostly on the basics. So first I will complete what kind of pipettes available in Eppendorf, so that when she is speaking about basics, very easily you can connect yourself with your problems and the what kind of model you can choose it from Eppendorf. So that's our idea. With this background, just I will get into my presentation. In pipette, there are two kind of pipette. One is called air cushion pipette. So here what is happening when you are pressing this plunger, when you are pressing this plunger down, whatever air inside it will goes down, and when you are releasing the plunger, then the air will come back to the piston. Between the piston and the sample, always a air gap is here. Due to that, this pipette called as a air cushion pipette. And whatever problem you are having with your pipette, This is mainly because of the air here. This air is the main culprit which create uncomfortness to you. And if you know how to handle this air properly, then you will have a lot of comfortness when you are handling the pipette. Then the next set of pipette is called positive displacement pipette, where the whatever piston inside the pipette it built inside the tip. So when you are aspirating the sample directly in touch with the piston. Absolutely, there is no air gap between the piston and the sample. I will show you a few videos later on. With that, you can get a very clear idea like what is positive displacement pipette. I hope some of you already using it, and this video mainly for the people who are not so far used it. Okay, I will go to the next slide. So in nutshell, in event of for manual pipette in air cushion, we have a model called Research Plus and Reference 2. And in a positive displacement, the manual pipette is called M4. If it is an electronic pipette in air cushion, we are having a Explorer Plus, and in for positive displacement pipette, we are having a E3, E3X. Anyhow, when I go one by one, it will be very clear to you. Okay. So in air cushion pipette, as I said, we will discuss about Research Plus, Reference 2, and Explorer Plus. What we need to look into pipette when we are choosing a pipette? What are all the things we need to look into that? Number one, ergonomics. Number two, flexibility. Number three, robustness. The ergonomics means when you are handling a pipette, you should not feel the pain of the work. It should completely fit into your hand so that you are comfortably handling the pipette. Right now, the biggest worry with most of the biologists is injury due to pipetting. There are so many people when they do a continuous pipetting, they will have a pain in their finger. If they are not taking care of that pain, then slowly it will go into the wrist. From the wrist, it will reach their neck. Once it's reached the neck, and if you consult any of the neurologists, they will suggest you don't do pipetting in your lifetime. I feel the biggest punishment to any biologist in their lifetime is not touching the pipette only. So due to that, when you are choosing a pipette, always look into certain parameters, and in detail, myself and Priya, we will explain you how to avoid RSA also. So ergonomics means pipette should not have a heavy weight, it should be a low weight. And when you are pressing the plunger, it should have a very smoothly go inside and comes out, low operating force. When you are connecting a tip, you should not with a bang you can connect a tip with your nose cone. I can show you in detail about that. Then the faster volume setting, because sometimes you never realize, for example, now we are having a 10 to 100 pipette, how much time it needed for you to go from 10 microliter to 100 microliter makes all the difference. Yeah, in detail we can see it here. So the first one is a spring loaded tip cone. Normally, when we observe the pipette users globally, there are a lot of people having a habit of banging the pipette with the tip box. Even some places, if that tuck tuck sound when they are banging it, if it is not reaching their air, they are not confirm that tip is connected properly. So even sometimes people say, pipette is a stress releasing equipment. If they are angry with someone, then the amount of banging also increase. But definitely it makes a lot of issues to you. Here in this picture, you can see this is with the Research Plus. Whatever way you are taking it gently or bang it, the tip will stay in the same position. You can see it here. This is with one of my competitor. When you take it gently, the tip will stay here, and if you bang it too much, the tip will move from this place to this place. It means the working space in the tip is going to reduce, and also the moment if it goes beyond the permissible limit, for ejecting the tip, you need to spend a lot of energy. That energy only create RSA, repetitive strain injury. So by avoiding that, you can have a good health, and you can have a reproducible results. So instead of requesting customers to handle like that, we created a pipette with a spring loaded function. Whether it is a single channel or multi-channel, just you can see when you are pressing it, the nose cone will slightly get into the tip. So due to that, whether you are taking it gently or banging, the tip will stay same position in whether it is a manual pipette or electronic pipette. So all our pipette up to 1 ml, it will have this spring loaded function. Then, as I said earlier, in Research Plus, it needs just 9 turns to from lower volume to the upper volume, or from higher volume to lower volume. You want to get just its need 9 turns only. So whenever you are choosing a pipette, always make sure that it's not having it's not need more turnaround for bringing the lower side or higher side. Then the very interesting point, how many digit of display these pipettes are having, that makes all the difference to you, and where the display is positioned also makes all the difference. For example, now in it is having a 4-digit display, and it is the other side of your holding side. So for example, in this pipette, this is your hand rest, and the display is here. So what will happen when you are aspirating a sample, the display is in between your palm and the pipette, and after aspirating the sample, if you are having a doubt how much volume I aspirated, then what you will need to do with the sample, you need to tilt your pipette and see that. By the time, if you have a little bit infectious sample, something like that, it will get into your pipette and it will contaminate your pipette also. So when you are choosing a pipette, so just check how many digit display it is having, where the display is positioned in the pipette. And also very interesting thing is that the amount of increment you can make it with the pipette makes all the difference. Straight away I can use my competitor Gilson name here, Gilson pipette. If you take a 1 ml pipette, 200 to 1 ml pipette, just you take it, their increment in the pipette is 2 microliter, whereas we are having a 1 microliter. I'm not saying only in Eppendorf we are having a 1 increment. There are pipettes available. So as a thumb of rule, when you are choosing a pipette, just check what kind of increment this pipette can make it. Because this biggest advantage, for example, in 1 ml pipette, if you want to set a 7 microliter, in Eppendorf it is possible since it's having a 1-digit increment. Whereas here, either you can do it 776 or 778 only. So that way you can save some amount of reagents, because wherever you want to do it 777, since that option is not available, you are going to do it 778 only. This 1 microliter, sometimes if you are doing a sequencing or anything, this kit is very expensive. You will lose some amount on unnecessarily due to the incapability of that pipette. So when you are choosing a pipette, just think about this aspect also. Okay, then easy maintenance, chemical resistivity of the piston, and whether it is a fully autoclavable or UV resistance, because some of the pipette available in the market, it is not having a UV resistance. In case if you are using for cell culture or kind of thing inside the laminar flow, you can do it UV radiation. If pipette is not capable enough to withstand, then you will have a problem. So when you are buying a pipette, just think about that, and autoclavability of the pipette also, because some of the pipette, they say you need to remove this X component, Y component, then only you can do autoclave and all these things. That is very difficult for you. Even if you are removing it, again you put it back, you are not very sure that whether it is carrying any contamination to the pipette or not. So when you are choosing a pipette, and that too if you are handling an infectious or contaminating a sample, this is a very important point. You need to look into that, whether it's a fully autoclavable or whether it's having a UV resistance. And easy maintenance, as I said, in Eppendorf, just with the click of the button, you can remove this lower part. There is a good video available in our website, how to open the pipette. If you need, I can share that video also, in case if you are using a Research Plus. Very easily you can remove the pipette. If you are having our earlier generation Research pipette, it is having a thread kind of thing. We need to unscrew the pipette and disassemble. So I hope mostly you will have this our Research Plus, because last 10 years we are selling this Research Plus only. So in this pipette, there is a, if you just you need to remove the nose cone first, just you need to push it down, then there will be a push to release mark will be here. Just if you push it up, then the lower part will comes down. Then very easily we can remove everything like this. There is a spring and piston. This is called piston. So this is called lower part nose cone. So sorry, this is a ejector sleeve and nose cone. So very comfortably you can take it. Maybe during our no pipette servicing and calibration discussions, we will discuss more about that. So no need of any tool. In case if you are having a multi-channel pipette, there is a lever here. But just moving either left side or right side, we can remove this lower part. Then if you just there is a notch here, just we need to push it down. By doing it, we can open up the pipette, and you can see the speciality of append of multi-channel pipette is that there are 8 pistons here. 1, 2, 3, 4, 5, 6, 7, 8. It means 8 individual pistons available for every channel. Even any one of the channel goes out, until our engineers or this pipette get serviced, you can use it rest of the other 7 channels just by removing this piston. So whether it's a single channel or multi-channel, you don't need any tool to open this pipette. And why I'm insisting on that, some of the pipette it is not that easy to open up the lower part and for cleaning purpose. So whereas with append off, very comfortably you can move it. Then we are also having another pipette. It is called reference to pipette. The speciality here is that there is no separate tip ejector in this pipette. Here this pipette will have a 3 stop. Normally all the pipette it will have a 2 stop. This pipette will have 3 stop. The reason is that normally if it is a 2-button operation, what is happening when we are aspirating a sample, when we are releasing it, the whatever the air which touched the sample, it is coming back to the pipette. So why we need to release the piston? Just to remove, just to eject your tip. So for that reason, what we decided here in this reference to pipette, after dispensing your sample, we are not going to release the piston. Rather, what we will do that after dispensing the sample, we will hold our finger, come out of your sample tube, then we will eject the tip, then only we will release the piston. So especially when you are doing a cell culture work, you want to avoid contamination happening in your cell culture work. This pipette is a much better pipette for you. Here we are having a single channel as well as a multi-channel. The only thing you need to remember here, last stop is ejecting the tip, because when you are using a normal 2-button operation for a very long time, it takes some time to adjust yourself to find a second stop and third stop. If you are able to do that, this pipette is much better pipette than the normal 2-button operation, because here just remember your finger going to move only in one direction, whereas with this pipette your finger for aspirating dispensing it will move in this direction, and for ejecting the tip from here we will move our finger to this position and press the tip ejection. So your finger always have a circular motion with the 2-button operation, whereas in reference to pipette it will have only one direction movement. By that you are avoiding the stress to your finger also. So this pipette is very good. Only thing you need to remember, where is the second stop and where is the third stop. Okay, so now I'm coming to the second part, that is positive displacement pipette. So as I said, here the piston directly in touch with the sample. Absolutely there is no air gap between the piston and the sample. Okay, so what is the advantage here? What is the advantage for you? Since it's having a direct contact, comfortably you can handle highly viscous samples like glycerol, twin 10, twin 20 kind of samples, or highly vapor pressure samples, or detergents containing like master mix kind of thing, very comfortably you can use it. And also, since air is not coming back to the pipette, there is no contamination to the pipette also. So what is the main difference between Research Plus and this pipette is that the tip what you are using, it is a combi tip made out of two material. So due to that, this tip is not autoclavable. So either you can buy a sterile tip from Eppendorf. If you don't need any sterile, then you can buy normal quality tips also. So mainly this pipette is useful for handling chemicals and glycerol kind of thing. The sterile issue is not a main thing here. And even with the gloves, this pipette very comfortably sit in your hand. And also it is having a stand just by in our normal pipette stand itself. You can hook it. The moment you do it, the display it will go to the sleep mode. It is not an electronic pipette. Only for display we are having a small button type of battery. So it is not very expensive also. And we are having a 9 different tips for this, starting from 0.1 ml to 50 ml tip. So here with one pipette, by changing the tip in a manual pipette, you can handle 1 microliter to 10 ml. If it is a motorized electronic pipette, up to 50 ml, you can handle that. We can discuss about that. So for example, now if it is a 0.1 ml tip I am connecting, the minimum volume what we can do is 1 microliter. So this minimum volume 100 times you can dispense. One aspiration, then continuously you can dispense 100 times. So the only limitation in this pipette is that it will go in the multiplication of the initial value. Like for example, now if you are taking a 0.2 ml combi tip, then the initial volume, because 0.2 ml divided by 100 is a 2 microliter. Then the next step, 2 microliter, 2 become 4, 6, 8, like that only. So in between, if you want to set a volume, it is not possible with this pipette. In case if you are choosing an electronic pipette, then you can have a closer volume range. I will show you later on. So 20 different volumes per tip size, we can do it with this pipette. As I said, in case if you want to have a high quality tip of combi tip, then you can go with our BioPure quality. It comes in an individually wrapped packet. So here it's endotoxin free, RNAs, DNAs free, whatever you ask, everything is free out of this quality. So as I said, you can use this pipette normally. To give you some idea, just I will use one or two videos here. So
using standard pipettes for high vapor pressure liquids is problematic. Examples are ethanol and acetone. The liquid gets pressed out of the tip due to an increase of the air cushion volume, and the tip starts dripping. Thus, the correct volume cannot be dispensed. Molecules enter the space above the liquid surface. These molecules increase the volume of the air cushion. In this process, the liquid is getting pressed out of the tip. There is no air cushion in the combi tip advanced, only the liquid aspirated. The vapor pressure has no chance to build up and the molecules stay in the liquid. No dripping occurs. The volume dispensed is always equal. Your results are reproducible and reliable. Therefore, Eppendorf recommends the Multipad M4 Combi Tip Advanced system for high vapor pressure liquids.
Same way, the other most difficult sample handling is the glycerol. Normally, what we found, some of the users, they cut the front portion of the tip and use it for glycerol kind of sample. That's not a right way of doing it. The moment you cut down the length of the pipette, length of the tip, it will affect no the manufacturer's calculation of air pressure into that pipette. So that will make you lot of problem in dispensing the sample. The right way of doing is you can use this kind of positive displacement pipette.
As you all know, pipetting viscous liquids causes problems. Examples for viscous liquids are glycerol and yogurt. If you are pipetting these fluids, remainings of the fluids stay in the tip, and these remainings are always different. Thus, your results are not reproducible. I will show you in a little experiment how this happens. I'm going to put a tip on the pipette, aspirate some glycerol, apply this glycerol to a smooth surface. The surface resembles the inside of a tip. If I now move the surface up, you can see how the glycerol moves down the surface. That's the same thing which happens inside the tip. But some of the glycerol stays at the surface. If you now use a wiper, you can remove it all. This is the same thing which happens inside a combi tip. If you move the plunger inside the combi tip back and forth, you can see that here are wiper blades which remove all the liquid out of the combi tip. Thus, your results will be reproducible and reliable. Each dispensing step of the multipad M4 provides the same volume. Your results are reproducible and reliable. The piston of the combi tip Advance removes all liquid from the tip surface. Therefore, Eppendorf recommends the multipad M4 combi tip Advance system for experiments with viscous liquids.
All these videos is available in our website as well as in YouTube. If you type it Eppendorf videos in YouTube, you will get it all kind of videos for and even we are providing a lot of solutions for whatever day-to-day problem you are having it. As we discussed, even sulfuric acid of 97% or ethanol of 98% or nitric acid of 65% concentration, very comfortably you can use it with this positive displacement pipette. Okay, so the manual pipette, one of the biggest problem is that aspiration and dispensing speed. In case if you are working in a 96 well, the same speed of aspiration and same speed of dispensing, you are not doing it. Due to that, what is happening? The air flow inside the pipette get changed, and that also makes some kind of trouble for you to get a reproducible results. That way, these electronic pipettes will really help you in a way that it will have a 8 as the maximum speed, 1 as the minimum speed. In Priya's presentation, she will cover how a speed of aspiration and dispense will help you to handle a different sample. So in a manual pipette, even from morning to evening when you are doing, it's not going to be the same speed. Or in case if you are 2-3 people are doing experiment and you want to compare, it is very difficult for you. Whereas with electronic pipette, if you set aspirating and dispensing speed, then know whether they are touching it gently or fast, it will move in the same speed only. So that way this electronic pipette will give you a lot of reproducible results. As we said, the operating force in a manual pipette, it is a little bit higher in comparison to the electronic pipette, since there is a motor inside. So comfortably this pipette will dispense the sample, and this pipette also having multiple functions. Like I will come to that. So whatever we are discussed about manual pipette, same it will applicable for electronic pipette. When you are choosing electronic pipette, you need to check what is the weight, how it is balanced, how much force is needed, where is the display, how easy to use, and size and height. It means when you are holding it inside the laminar flow, it should have a very clear vision to you. If you want to check the weight balance, just put it pipette in your fourth and fifth finger and just hold it. If you are not feeling need to grip it, then this pipette is not well balanced. If you are not having any feeling, then this pipette upper portion and the lower portion weight, it's very much balanced in the middle of the pipette. Same way, the display in the pipette, whether you are sitting, standing, or holding up, or sideways you are looking, the display should have a very clear display to you. Whereas with the append off, you don't have any issues. Whatever way you are doing, comfortably you can handle this pipette. So as we discussed earlier, same spring-loaded function available in single channel and multi-channel of this pipette, and it is chargeable. The beauty about append of electronic pipette is that it is having a lithium polymer battery which can be charged, and once this pipette is fully charged, we can do it 12,000 dispensing steps or 1,400 strokes in mode of mixing with a speed of 5, or you can do 196 well pipette. And the best thing about append of electronic pipette is that during the charging also you can use this pipette. So we are having a two model. So the first model will have functions like pipetting, manual pipetting and mixing, dispensing, automatic dispensing. In Explorer Plus, in addition to this, we have other functions like multi-aspirate, diluting, sequential dispensing, reverse pipetting, and sequential pipetting. It also having a history function. It means if you are adding 4 different samples, when you are doing a 4th sample, if you are having a doubt how much I dispensed for my first sample, then this history function is very much useful to you. Now, by going back, you will see last 10 pipetting value, what speed you did, what volume you did. You will get a full information. When you are doing 11th one, then the first one automatically get erased. Then the 11th one become a first one. And it also having a like auto dispensing mode. Just to give you was one idea, I use this video, especially when people are using a 96 well plate for PCR or real time. This pipette is a very good one, and that to this auto dispensing mode, very comfortably you can handle this. And I think it's the volume 8 times we are going to dispense. Same way, we also have a multi-aspirate function in case if you are doing a lot of centrifugation. If you want to take it the supernet at Ungo, just you can program it. It will aspirate only that particular volume. Same electronic pipette available with a positive displacement pipette also. So here we are having a 2 model in E3. It is having a pipetting, dispensing, and auto dispensing mode. And in the electronic model, we have a sequential dispensing, aspiration, then titration also. So sequential dispensing means every dispense you can change the volume also. If you want to make a standard curve analysis like 5, 10, 15, 20, want to make a serial dilution, this is possible with this sequential dispensing also. As I said, in the electronic pipette, you are having a you can set a closer volume range, because in the manual pipette, as I said, first volume is 1 microliter, then second 1 plus 1. Then like that it will go 1 microliter, 2 microliter, like that. Here same competitive we are using, but first time you can dispense 1 microliter, then the second volume it can be 1 plus 1, it means 1.1, 1.2, like that. You can make a closer volume setting here. For example, 0.2 ml tip you are using, the first volume is a 2 microliter for 100 times you can do it. Then second volume will be 2.2, 2 plus 2 you can make it. So very closer volume setting can be done with this electronic pipette, and also very comfortably you can handle a different format tubes also. Here if you take a 2.5 ml combi tip, it go up to bottom of the 50 ml combi tip also, and any format of 96 or 384 well plate can be used with this pipette also. And recently we introduced a new electronic pipette. It is called Move It, a brand name. Application wise, it's having a adjustable tip spacing multi-channel pipette. So in case if you are using a 24 well and you want to do it reformatting in a 96 well plate, what you can do that, just aspirate the sample in a 24 well plate, then readjust the space between the tip, then you can do it in a 96 well plate like this. From here you are aspirating it, and here you are closing the gap. So with that, very comfortably you can handle a 96 well plate also. Next year we are launching the additional models. By that, from 96 to 384 also possible. Right now we have a manual as well as electronic version. So we have a single channel, sorry, 4 channel, 6 channel and 8 channel pipette. Next year we are launching a 12 channel also. So right now this is what available. The biggest advantage with append off than any other move it pipette like tip adjustment pipette in the market is the lower part is fully autoclavable. We are not using any tubing. Just check whatever pipette available in the market. If you ask, they said no, it's not possible to do autoclave. Whereas with append off, you can do complete autoclavable. All our multi-channel pipette, the lower part, it's a 360-degree rotatable. It means in a plate, any direction you can dispense your pipette. The biggest advantage, 70% time saving with move it adjustable tip spacing multi-channel pipette. It means from 24 well to 96 well you are reformatting. Normally you will do it with a single channel pipette. Whereas the moment you start using a append of 4 channel or 6 channel, you are going to save quite a lot of your useful time from doing pipetting. And also append of electronic version, lower part is autoclavable. If it is a manual one, the full pipette is autoclavable, so that you are protecting yourself as well as your sample. If it is a 4 channel pipette, it can be used for 12 well, 24, 48 and 96. You can reformatting from any of these format, and also from 1.5 ml, 2 ml tube or 5 ml tubes in a tube rack. So after your centrifugation, you want to load it your 96 PCR plate, very easily you can do it with this 4 channel and 6 channel pipette. So from tube to 96 well plate, it is possible in all 3 models. Only catch in the 8 channel pipette is that the distance between the channel is a 14 millimeter. So you need to find a tube rack which is having a 14 millimeter. Even no, because normally it will be slightly more with a lot of tube rack. Even our append of tube rack in 1.5 ml tube, the distance between these 2 tubes is 18 millimeters. So standard tube rack not useful with 8 channel pipette, whereas with 4 and 6 you can use it, because the distance between 2 channels can be from 20 millimeter or here 33 millimeter. Due to that, any format of 1.5 ml tube rack can be used with 4 and 6, whereas with 8, in case if you are choosing it 1.5 ml tube to 96 well plate, it is possible. Only thing you need to take care is the distance between the 2 tube in that tube rack. It should be 14 millimeter only. Yeah. Okay. I am slowly coming to my end of my presentation. One of the biggest discussion in the research side is to minimize the plastic usage in a lab, because these plastics can leach out and create a lot of problem. That is one side. The second side, degrading the plastics, that also biggest issue. So how to minimize that? By choosing a different kind of pipettes, we can do it also. For example, now if you are going to dispense a highly concentrated chemicals from a bottle, or in a lab when you are doing an experiment, some Same, in a lab, different people wants to take a sulfuric acid from a bottle. Using a pipette, they can use this kind of bottle top dispensers, whereas no, it can be very easily you can aspirate the sample. Just to show you idea, I want to use this one video to you. This fuming acids, what will happen when we are aspirating? It will absorb the air from the moisture, then it get diluted. So here we are also having an adapter that you can connect. So whatever air goes inside the pipe.
Fuming acids get diluted by air humidity entering the bottle top dispenser. Simply screw on the drying tube and fill it with moisture absorber to avoid this effect.
We are also having a spiral discharge tube. It can be in multiple tubes. Very comfortably, you can dispense your sample also. In case if you are wants to use it with a cell culture, you can connect a filter here. By that, whatever air goes inside, it get filtered out, so that there is no contamination. And the good thing about this dispenser is that with bottle, complete system can be autoclavable. So in case in cell culture you want to use it, before loading your media into that, and you can connect and do autoclave everything. So this is for titration. In case if you are doing a manual titration, just by rotating this it will dispense, and once color change, you take your finger and you can read it from this display. By that, very clearly you know how much volume it dispenses. So for having accurate results, you can use this dispenser. And for cell culture, we are having a pipette gun. Here, this nose cone and this area, it's fully autoclavable. It is also having a display for charge, how much it is having it. If it is all three line, if it is blowing, it is fully charged. Once charge comes down, one by one, these light will go off. It very clearly tells you that it's time for you to recharge the pipette. It also comes with a 2 stand. With this, you can hang up the pipette inside the laminar flow, or this is another stand we will provide. With that, with the serological pipette or glass pipette, now you can rest it inside your laminar flow also. And in case you don't want to have any sophisticated dispenser, you can use this instead of a bulb in your lab. So any harsh chemicals can be used with this. This is a fully autoclavable. By just connecting it, by pressing this, you will create a vacuum. By moving this lever up, it will aspirate the sample. By moving it down, it will dispense the sample. With this, very comfortably, you can handle different sample. I hope I have given a full view of our liquid handling system, and each pipette where it need to be used also you might have understand from my presentation. In case if you need any clarification or any information, feel free to contact us. So now it's time for me to hand over my presentation to Priya. Priya, you can take over, Priya.
Yeah, first, real quick, Babu, Jason here. Yeah. Thank you very much for that presentation. I appreciate that. We are running behind, so we are going to jump right into the next presentation. But before we do that, I do want to remind all of the attendees to please, if you have any questions, you can put those in the chat box. And I also listed all of the experts that are joining us from Eppendorf. One of them can jump in and answer your question in the chat box. Okay, while Priya is setting up her presentation, let me introduce her. She is the training manager for Eppendorf. Her region is India, Middle East, and Africa. Priya, you ready to go?
Thank you very much, Jason, for the introduction, and thank you, Babu, for your session on the pipettes. Could I just have some confirmation if my screen is already visible to all of you?
It is.
Yes.
Yeah, thank you very much. So what I will be taking you through for the next 45 minutes is some basics on the pipetting, although sometimes we do know that we've been doing pipetting for a very, very long time. There are a few things which are generally left unexplored when we look at the pipetting aspects. So this is what I will be focusing on for the next 45 minutes. Jason, please feel free to indicate to me if I'm overrunning the time by any chance.
Will do.
Yeah, sure. So what I would want to quickly give you an introduction is how Eppendorf started with the liquid handling portfolio. So we had Eppendorf Foundation in the year 1945, and the year 1951 was the invention of the first pipettes. You can see here, these are the pipettes which are more like your injection syringes. You have these button syringes for your insulins, so it's more like that. And then we've evolved a long way right now with regards to how the pipettes look and how they function. The changes in the pipettes that have been brought around are basically with the kinds of requirements that the market has brought out towards companies like Eppendorf and other pipette manufacturing companies. So this is how the Eppendorf pipette portfolio, the portfolio has grown over years. But generally, when we have, too many pipettes in the lab, so how do we decide which pipette is the right one that we need to use? So that's the first question that we need to always ask when we want to start using the pipettes, considering that we might have an array of pipettes that's available right in front of us. And for that, what we are generally looking at is the accuracy and precision of a pipette. But before I go about talking about what is accuracy and precision, let's try and understand what is inaccuracy and imprecision. So accuracy is basically the delivering of the different volumes that we want to be looking at, and precision is the number of repetitions that we have and how these repetitions are performing across what we need to be looking at. So typically a scenario that we will look at is something like this, where we have a pipette which is performing both accurate and precise. To put it in a little bit detail for you, or a little bit more explanatory format for you, you could see here that if the desired volume that I want to be dispensing is 500 microliters. So this is a situation where neither is the volume close to 500 microliters, nor the number of repetitions that we do are bringing the volume any closer to 500 microliters. So this is a scenario which is both inaccurate and imprecise. Here you could see that the volumes are over repetitions, the volumes are same, which means I have a precision, but the volumes are not close to what we want to dispense, which means it's inaccurate. But the typical scenario that we would want to have is something like this, where the pipetting basically is accurate and precise. So if you look at generally in the specifications of your pipettes, there you have something which is mentioned as the systematic error and the random error of a pipette, which I'm sure Jason will be focusing more during his session as well. So you could see that the systematic error is equivalent to the inaccuracies and the random errors are equivalent to the imprecisions. So to summarize the whole thing, an inaccuracy is a deviation between the actual volume delivered and the selected volume which is set on the pipette. For example, if I set a volume of 500 microliters, then how much of deviation I have across 500 microliters is what is considered as the inaccuracies. Imprecision is the deviation between the individual volumes delivered by the pipette which is basically measured in terms of the standard deviations. In other words, your imprecisions can also be called as the reproducibility of the pipette. The general assumption when we look at the inaccuracies and the imprecisions is that these are contributed by the performance of the pipette alone. But if you look at the performance of a pipette, the performance of a pipette could be influenced by a lot of parameters, the very first being the pipetting principle itself. So choosing the right pipetting principle itself could contribute to how well or how good is the accuracy and the precision of the performing task. So Babu has already explained this, but I will also take a little bit of more time to explain this. So if you look at this, we have two different pipetting principles. One which is called the air cushion principle, which are your conventional pipettes. Okay, most of the conventional pipettes have what they follow called an air cushion principle. The second pipettes, or the second principle that we're talking about, are the positive displacement principle. The basic difference between the two principles is how the piston is positioned. So in the air cushion pipette, you can see that the piston basically is positioned inside the pipette. However, in the positive displacement, the piston is positioned in the tip. So this becomes the basic difference between the two pipetting principles. And an air cushion pipette always has an air gap between the piston and the liquid. And when we adjust the volume of the pipette, we basically adjust the air gap that is present so that the volume that is aspirated and dispensed is equivalent to the amount of air that is getting displaced out from the pipette. However, when we look at the positive displacement pipettes, the piston directly comes in touch with the liquid and there is no air cushion which is present here. So this is basically one of the most important contributing factors when we have to decide or when we have to see how the pipette is performing with regards to the task that we are looking at. I will come more in detail about this, how these can basically influence your pipetting as well. Before we go further, the general assumption is all pipettes, it's always nice to use a manual pipette, but then why do we use an electronic pipette? We might have repetitive tasks. For instance, imagine that I have a master mix that is prepared and then I would want to dispense equal volumes of these master mix into multiple wells. Now, if I have to use a single channel pipette, or even if I have to use a multi-channel manual pipette, for every dispensing that I want to do, I would have to also do an aspiration. So an aspiration has to necessarily be followed by a dispensing. But when we use an electronic pipette, the advantage could be that I could have a single aspiration that is being done, and then I could have dispensing done into multiple wells. What does this mean to me as a user is I could really get rid of a long pipetting task. So an electronic pipette generally is much better when we have repetitive tasks which are performed. However, adding on to this, you could have constant pipetting speed. Adding on to what Babu explained in his presentation, if you can see that electronic pipettes have the possibility of speed adjustments during the pipetting tasks. So when I have a constant pipetting speed, I will have definitely higher precision, which is higher reproducibility of the pipetting task. Similarly, an electronic pipette could offer you the flexibility of working with multiple functions. Like I could have something like a dispensing function, a mixing function. I could have functions which, which is like multiple aspirations, a sequential dispensing. So all of these different functions makes an electronic pipette much more flexible than a manual pipette. And this would mean for the user a reduced workload and also saving a lot of time. And finally, last but nevertheless the least, are the low operating forces the electronic pipettes could offer. Now, why am I bringing in electronic pipettes here is just because to give you an idea that both electronic and manual pipettes could work with both pipetting principles of either an air cushion or an electron or a positive displacement. You could relate this back to the kind of pipettes Babu has introduced during his presentation, and I'm sure there are definitely few of you who are already using both pipetting principles in your labs. Now from here, I'm moving on to another, or to just give you an idea of what can be the influence of manual versus electronic pipetting in your assay setup. So for example, if you look at, this is a paper where they've worked with manual versus electronic pipetting in the setup of NGS using the ion torrent system, and you can see very clearly here. Let's not even bother to look at all of these situations here. If you can just look here, you can see that the standard deviations and the percentage CVs are definitely much better when using electronic pipettes. And you could also see that from user to user, the variations are comparatively much more lesser when using the electronic pipettes. And if you can look at the loading densities, the chip loading densities, you can see that the electronic pipettes definitely give us a much better chip loading density, which means automatically we are also going to have better reads on the NGS when using electronic pipettes for loading. Now from here I move into the different air cushion pipetting techniques. So I've already introduced the air cushion pipettes and the positive displacement pipettes to you. But of course, if you look at the air cushion pipettes, be it manual or electronic, we could have two different pipetting techniques that we could follow there. A forward pipetting, which is generally recommended for any aqueous solutions or diluted acids and alkalis. Reverse pipetting, which is generally recommended for any special kinds of liquids that we might have. I will come into the different liquid types in a little bit, but if you look at this, sorry for that. So what is the difference between a forward pipetting and a reverse pipetting? Now, all of us know that the air cushion pipettes, the plunger of the air cushion pipette or the operating button of the air cushion pipette has two stop positions. Now, a forward pipetting is what we typically do as a pipetting, which is we press down till the first stop of the operating button, aspirate the liquid into the pipette or into the tip, and then when we dispense, we do what is called a blowout, which means we press till the second stop of the plunger or the operating button to dispense out all the liquid. This is a typical way of pipetting, which is forward pipetting. The reverse pipetting is just the other way around. So for aspiration, we press the button till the second stop. So which means we're aspirating liquid more than what is set on the pipette. And when we dispense only till the first stop, which would also mean that the extra aspirated liquid will stay back in the tip and we do not perform a blowout here. So this is basically the difference between the forward and the reverse pipetting. I will also explain to you when and how would this really help when we're looking at the pipetting tasks. The next parameter which could also influence your inaccuracies and your imprecisions are the immersion depth, especially when we have new users in the lab, or even if we have users who have this myth considering that, unless I go to the bottom of the tube and mix, I'm not going to have an homogeneous mixing that is happening. So just remember that the tip that we are using is also a plastic. As much as her tip has a wetting property on the inner side, it also has a wetting property on the outside of the tip. So remember that I will also have a little amount of liquid that is held on to the tip on the outer side, which is basically a loss of the liquid from the source. Or if I have something that is sticking onto the edge, that would also mean that I'm taking extra volume into the destination. So here you can see that there are recommended depths, the optimum immersion depths that have been mentioned for different volumes of pipettes. You can see here that even for a 1 ml pipette, I could have a maximum immersion depth of only 2 to 4 millimeters into the liquid. So definitely this is not the right way of immersing your tips into the liquid. very typical correct way of pipetting. For aspiration, do something called as a pre-wetting. A pre-wetting is aspirating back and forth into the same source. And always remember to hold the pipette vertically. Now, why do we have to hold the pipette vertically is also because if you remember my first slide, I did indicate that there is an air cushion that is present inside the pipette. The minute you change the angle of aspiration, automatically there's a dispense or there is a displacement in the air that is present inside the pipette, which would automatically also mean that the aspirated volumes are going to change. And always remember to release the operating button very slowly. We know that initially when we start using the pipettes, we tend to release the operating button very fast. Now, when we do that, this would just mean that we are contaminating the pipette completely. Okay, so after the aspiration is done, when you dispense, remember to tilt the tip against the tube wall to an angle of approximately 30 to 45 degrees. And then after the dispensing, now provided that we are doing the forward pipetting and we're doing a blowout. After you do the blowout, remember to pull the pipette out from your vessel and then release the operating button. Otherwise, you are actually creating a lot of aerosols inside the pipette, which could then become a contaminating issue in your pipettes. So this also has to be considered when you're working with pipettes. Just to give you an idea of how much your pipetting, your correct pipetting technique can influence your results, I have here a data which shows how much can be the influence of pipetting on cell cultures. So you can see here, these are different OD correlations or different cell numbers that we're looking at. So you can see two different scenarios here. I have no mixing between rows and different aspiration angles and heights. You can see this. So this is one of the contributing factors to your pipetting, where you can see that there is a huge difference in terms of the cell seeding numbers. But of course, when we ensure that we are mixing before pipetting for each row, and we're also holding the pipette upright and at a constant aspiration height, you can see that the cell numbers are very, very similar, and we have very minimal differences in terms of the pipetting efficiencies. So generally we would have assumed that, the pipette is not performing, and that is why every time that I pipette, I'm getting a different volume or a different cell density. But the reason could just be that we're not having the right pipetting technique. Now, coming to the different liquid types, I already told you that whether I choose a forward pipetting or a reverse pipetting, or whether I choose an air cushion pipette or a positive displacement pipette, would more so a lot depend on the kind of liquids that we handle. So for aqueous solutions, we could very comfortably use an air cushion pipette with a forward pipetting, and you could have very minimal variations that you might see. But when we handle different liquid types, maybe viscous or high vapor pressure liquids, then we could have very different performances of the pipetting task owing to the physical properties of these liquids. Few of them, Babu has already kind of given you an idea in his presentation with the two videos that he has shown you, but I'm also going to take you through this and explain a little bit more in detail. So generally, when we're looking at viscous solvents, what we try and do is we try to cut the tips of the pipette. So if you see here, the deviation in terms of the percentages, in terms of the inaccuracies and the imprecisions, even when I have a tip that is cut to handle only aqueous liquids, you can see here that there is a deviation that we are able to see in terms of the inaccuracies. And imagine what happens when we cut the tip when we're using glycerols. We're basically contributing a lot to the inaccuracies of the performance of the pipetting task. Also, the imprecision is also affected when we cut the tip. Now, why do we generally cut the tip? The reason is because I have a very poor flow behavior of the liquid. I don't have accurate volume deliveries. So I see that, maybe if I cut the tip, then it's much easier to handle the viscous liquids. What is the challenge that we have? A higher friction and an increased pressure that needs to be applied to transfer the liquid appropriately. So to avoid this, what we could do is, or just to give you an idea, what happens when I use a forward pipetting as against a reverse, or if I use a positive displacement pipet. You could see here, I'm not explaining too much in detail, but you can see from this chart here, or this graph here, that the positive displacement pipettes definitely perform much better for pipetting of viscous liquids. And that's exactly what is going to be the recommendation. If I don't have a positive displacement, the option would be to follow a very, very low aspiration speed and a very low dispensing speed with reverse pipetting. Otherwise, use a positive displacement pipette. Because a positive displacement pipette would mean that there is no air cushion, and I would also have an accurate volume delivery and a perfectly clean tip at the end of the pipetting task. With volatile liquids, we know what happens the minute we aspirate. We have the liquid that's dripping out of the pipette tip, and the reason this happens is because I have the evaporation of the liquid into the pipette cone, and the air pressure inside the pipette pushes the liquid out of the tip. And that is why we see the dripping. So to avoid this, what we could do is pre-wet the tip 2 to 3 times, and that would ensure that your air cushion is saturated. And once you have a saturated air cushion, you will no more have the back pressure that's created from the pipette by itself. Of course, you can also perform a reverse pipetting, but remember that would depend very much on the concentration of the liquid. And again, to give you an idea, you could see here that reverse pipetting to a LEM can solve the issue that you have, but of course the positive displacement is the best choice that you could consider. Dense liquids, so remember that whenever pipettes are calibrated, pipettes are always calibrated with water, a specific purity of water, a specific type of water, and these concentrations are according to the ISO 8655 concentrations. So a higher density would definitely then mean that I have a different weight of the liquid compared to that of the water. And here what happens is basically your air cushion inside the pipette behaves like an elastic band, and it could either elongate or compress depending on the density of the liquid. So here you can see that the higher the density of the liquid that you will have, the lower will be the volume that you will dispense. So it's very clearly explained here that, when I have the water which has a density of 1 milligram per microliter, you have ethanol which is of a lower density, then the volume increases. You have phosphoric acids or sulfuric acids which have higher densities, then the volume decreases. So how do we take care of this? Generally, you could have pipettes which have an adjustment on the pipette, and you could have a user adjustment that is being done. You don't need an engineer to come and do this adjustment for you. You could do this adjustment by yourself. 0 is the factory setting, which is basically for water, and there are some liquids for which the settings are already provided in the Eppendorf user manual. And typical solutions are foaming liquids. We have protein solutions, you have your PCR master mixes, you have cell culture mediums. All of these are, foaming solutions. The challenge that we have with these foaming solutions is whenever I have to blow out, or whenever I do a blowout, I actually increase the formation of the foam. And that basically leads to inaccurate volume deliveries. So what do I do to avoid this is using low retaining tips. You have tips which can retain very low liquids in them, and the advantage of using low retaining tips is that you will have very little liquid that is retained in the tip, which then would also mean that you would have very, very low foam that is being formed, and therefore the volumes are much better. So you could see here, this is a comparison of standard versus low retention tips and the residual liquids in the tip. So you can see here, whenever I'm using a master mix, I'm actually contributing a lot of liquid that is remaining back in the tip just by using standard tips. And of course, to give you an idea, I'm going to give you an example here of some essays which have been done where this is done for using qPCR, and you could see here the percentage error in terms of the systematic error and the random error of CQ for standard tip as against the low retention tip using either forward pipetting or reverse pipetting has been shown here. And you can see here that the low retention tip definitely gives you a very, a much better, much lesser CQ errors as compared to your standard tips. I have various data which are shown from the same paper. So you can see here the percentage uncertainty CQ drastically reduces when using a low retention tip. And of course, when you're using an electronic pipette, automatically this error comes even lesser as compared to a mechanical forward pipetting with a low retention tip. So the essence is to just tell you that using of low retention tips is definitely better when we are working with foaming liquids. The other type of liquids that we come across are cold liquids. You know, when we have something which is staying inside the fridge and we take them out, then automatically you will see that there is a shrinking and the expansion of the warmer air cushion that happens, because of which we will have inaccurate deliveries. So the only thing that we could do is let the solution equal bread to room temperature and then perform reverse pipetting. Warm liquids on the other side has a totally the other side of the effect on the pipetting. You will have smaller volumes which are delivered than set in the very first pipetting step, and then you will have larger volumes which are being set, and this can be avoided or this can lead to actually aerosol contamination in the pipettes because of the evaporation of the liquid into the air cushion of the pipette. And whenever we have air cushion which is getting contaminated with the aerosols, remember that these aerosols would definitely go directly to your pipette, and this has a lot of a lot of effects on your pipette. Obviously, you're going to have cross-contamination of samples, but also the next challenging issue that you will have is it could lead to the corrosion of the pipe, the inner part of the pipette. What can we do is you mix the pipettes, mix the tubes gently, and then you avoid the air bubble or the splashing. And whenever you want to pipe it, remove the stoppers of your tubes very, very carefully so that you don't generate aerosols. Otherwise, use tips which have 2 layers in them, which have dual filters in them, which can ensure that the contamination or the aerosols which are generated in your pipette are the least transferred into your pipette by itself. Otherwise, of course, you could use the positive displacement pipette. I'm going to run through the next few slides quickly. With blood and serum, obviously, you could use a reverse pipetting. You can see here what is the difference that you can see. There are multiple application notes that are available on the Eppendorf site, and you could have a look at these application notes, which talks in detail about all of these different liquid types that we've spoken about. So just to summarize the whole thing for you, so you can see here the different liquid types have different kinds of recommendations. The final recommendation, however, would be to use the positive displacement pipette. But if you don't have an access to a positive displacement, then using the given suggestions here can ensure that you will be able to have a better accuracy and precision of the pipette. And remember that it's not only the pipette which contributes, but also the pipetting technique, the type of liquid that we use, which will also contribute to the performance of the pipette. Now, coming to quickly the risk of contamination during pipetting. Of course, I did explain this a little bit to you in my previous slide. We know what aerosols are, so I'm not going into the details of what aerosols are, but how can they be created during the pipetting? Whenever I have small pipette tip openings, which means whenever you have all your lower volume pipettes that you're using, when you have liquid which enters with force, someone who's a new user in the lab and they don't release the operating button with care gently, or if you have droplets which are generated inside the pipette tip, especially if you're working with either foaming liquids or you're working with liquids like glycerols, then you could have liquids that are staying back but can also generate aerosols. Now, what happens when we are generating aerosols? The first thing that we are doing is You have all the aerosols from the pipette tip, which is moving into the nose cone of the pipette, or rather the air cushion of the pipette. Now, when it is moving into the air cushion of the pipette, remember that if I've handled sample A and the aerosols from the sample A is already staying inside of the pipette, when we're using sample B, we basically have to push out the air cushion and then aspirate the liquid, which means we are contaminating, or rather cross-contaminating sample B with the aerosols from sample A, which would mean that we could end up having false results or poor reproducibilities. We could have a lot of downtime for removing the contamination from the pipettes, and ultimately, remember, we would also have to repeat the experiments, which would mean that I would have to invest more on repeating these experiments. Now, why do I say this? Why am I really talking about contaminations? Two reasons. One is how, as a user, I can prevent contamination. Second, what is it that I can do to, or how is it that I can maintain the pipettes comfortably so that as much as possible, I can avoid contaminating or cross-contaminating these samples. So I've explained this, I'm not going into detail again into this slide, but you can see here that when I have dual filter tips that are being used, you will have the air cushion part or the piston part, which becomes now a protected area, and you will have very low amount of, rather no aerosols which are staying in the pipette, which means I can prevent the cross-contamination issues. Another thing that we need to consider when we're using the filters are, also remember that the filters by themselves can also have a kind of inhibitory effect on the results that we want to generate. That is the reason why whenever you're using filter tips, never ever cross the maximum volume of the pipette, and remember to use the right volume of the tip that you're for that particular pipette. For example, you could have a pipette which is a 200 microliter pipette, okay, and you could also have a 100 microliter pipette in the lab. And remember, most cases both of these use the same tips. And if I have a filter tip which is designed for a 100 microliter pipette, the position of the filter will be very different to what it is on a 200 microliter tip. So if I use a 100 microliter tip on a 200 pipette, you will invariably go and hit your sample on the filter. And if that happens, you are exposing your sample to the material of the filter. And this material of the filter could have inhibitory effect on the filter, on the assays that we are performing. To just give you an example, this is an assay which we have, which has been performed where the sample has been consciously brought in touch with the filter. Okay, so you can see here that there are different tips which have been used from different manufacturers. You have also a positive control and a negative control which has been used, and you could see that this is the Eppendorf tip that has been used, and you also have other manufacturer tips. And all of them have been processed the same way, where the samples have been brought in touch with the filter knowingly, just to show what is the inhibitory effect of the filter. So you can see here that there are filters which definitely have the inhibitory effect on the performance of your assay. This is on a PCR assay, and you can see here there is also a qPCR assay which has been performed where there is a huge shift in the CQ values, which is reflected in the samples which have come in touch with the filters. So remember that even when you're using filter tips, you need to be extremely careful in ensuring that you choose the right filter tips. Okay. Now a quick insight into ergonomics. So here you can see what does ergonomics means. So ergon and nomoi are two different words. So you have work and the natural laws of work. So ergonomics basically means the science of work, which means fitting the work to the person. Okay. Now ergonomics is a very serious factor to be considered whenever we're working with pipettes, because remember that pipette involves a lot of ergonomic factors. Babu has covered a little bit of this in his presentation, but I thought I will give you a little more insight into what ergonomics really is in terms of the pipetting. So we have a lot of factors like the thumb force. You have repetitive movements or repetitive motions which are used. And we know a lot of places where, you know, you have people who perform pipetting starting from the morning and going on till the evening. So all of these in totality could contribute to a lot of stress, a lot of usage of pipettes, and this in turn could also lead to what is called as a repetitive strain injury. So a repetitive strain injury, why does this occur, is because you know, we know that when we are pipetting, we're using the thumb the maximum. So when you continuously using the thumb of your hand, you will see that the muscles and the nerve which is running across from your thumb actually runs straight till your shoulders. And over a period of time, you could see that you will have a lack of endurance or lack of strength in your hands. And this, I could in turn pull in a repetitive strain injury into something called a carpal tunnel syndrome. And remember, if you have a carpal tunnel syndrome, technically your hand is unusable. So what is very important is to ensure that a prevention is better than a cure. You cannot wait for things to start and then say, you know what, let me see what is the solution for this. So how do I take care of this? Is these three things. Yeah, the work organization. Of course, I don't have to explain to you what work organization is. All of you know this better because you've been working in the lab for a very long time now. So I'm not going to touch into the topic of work organization, but what I'm going to be touching about is the performance of the pipetting tasks and tools, and a little bit of insight into the pipette maintenance, which will be taken forth by Jason in his session.
Hi, Priya.
So when you yeah.
Just letting you know, we're about 2 minutes remaining.
Yeah, I'm just going to be maximum, say 5 minutes into the session, and I'm going to be done by then. Yeah. So we're going to be using as little force as possible. Remember to take frequent breaks between your pipettings, and choose to use the right pipetting technique for you. These are some of the things that we could do. And when it comes into the pipette maintenance, this is not something which I'm going to be touching in full, but of course, I would want Jason to focus on this when we're talking about the repetitive strain injuries. An insight which I will stop with the next 2 slides. So remember that whenever you're calibrating the pipette, it is also important to take care of the tips that you use. Generally, the recommendation is to use the same manufacturer tip. But remember that if you're using other brand tips, they also contribute to the tip-to-tip variation. And remember, tip-to-tip variation is not a myth. You can see here, there is a difference in the systematic error and the random error when you use different manufacturer tips. And not only for the lower volume, but also for 10 microliters, also you will see that the same thing will also happen for 1000 microliters. Of course, remember for 1000 microliters, it will be comparatively lesser because the volumes that we're looking at is higher. Now, why does this happen? That is because of the quality of the tip that is getting used. So a tip orifice is equally as much as important as the pipette by itself. So remember that this will contribute a lot into the performance of the pipette. And finally, remember that depending on the kind of the solutions that you use, it is also important to clean the pipette at regular intervals, which I'm sure Jason and Edwin will be focusing in their next session as to how to open the pipettes and how to clean them. But just to give you a quick overview, for some reason, if you have the Eppendorf pipettes contaminated with nucleic acids, there are 2 different things that you could do. One is you could use a 4% sodium hypochlorite, remove out the lower part of the pipette, soak them in sodium hypochlorite for half an hour, and then keep them in water for half an hour, and then you could completely autoclave, dry the pipette, and assemble it back. So this is one of the simplest things that you could do with regards to the performance of the pipette. And with that, I come to the end of my session.
Thank you very much for that presentation. Indeed,
Yeah.
Be demonstrating some of the concepts and techniques that you discussed
Sure.
in my presentation. So we're right at 11:01. I think that gives us a good 15-minute break. We'll start back at 11:15 with my presentation and demonstration. Gives you a little bit of time to take a break. Hey, welcome back, everyone. I'm going to go ahead and get started with the final presentation for today. So, originally, Edwin Montas was scheduled to deliver this presentation, but unfortunately, due to circumstances beyond our control, he is unable to. So I will be presenting on how to calibrate a pipette on the new Artel PCS system using proper technique. And I'm going to demonstrate some of these concepts that both Babu and Priya mentioned in their talks earlier. So, beginning, let me get this thing to advance, there we go. Beginning this month, you all, the KAUST community, that's the researchers, right, students, postdocs, research scientists, lab staff, lab management, as well as our collaborative partners over in Research Park, all have the opportunity now to complete your own pipette calibrations and verifications using this Artel PCS system. PCS stands for Pipette Calibration System. The system is composed of the main unit. This is what actually does the calibration measurements. Here's the lid. And underneath the lid, that's where the magic happens. All right, this is where you will add your volumes to a vial inside to do the measurements. Around the outside, you'll see, looks like it's smiling and grinning from ear to ear. This is a touch-sensitive pad. This is what you use to open and close the system. On the side of the system, you have this here. You'll see it when you're in front of the system, and I'll demonstrate it as well. This is the barcode scanner. It's used to scan the reagent vials that you see in front of you. I'll talk more about those in just a minute. You also have, of course, the controlling system and software. Finally, over here on the left is a small printer. This printer prints out identification labels for your pipettes. So on that identification label is going to be the barcode. It's going to give you the pipette identification number, who owns it, and its location. It also spits out calibration labels. So after you do a calibration, on that, it's going to tell you when the calibration was performed, who did it, if it passed or failed, and then also when is the next calibration due. Now, not only can the Artel help you with and perform pipette calibrations, verifications, it's also a tool for helping you to brush up on your pipetting technique. Now, this was covered in previous presentations, so I'll be brief here. This graph shows you the sources of pipetting air, right? You can have things like environmental conditions. This is variations in temperature and humidity, right? So if you're pipetting a volatile solvent in a very warm and dry environment, right, you're going to expect to lose some of the volume to the atmosphere in the transfer. Systemic failure. That's the pipette. There's something wrong with the pipette. It's not working properly. It's not delivering consistent volumes. It's a failure of the pipette. An example of random failure might be an operator just not using the pipette to manufacturer's specifications, right? But most importantly, you can see that the largest source of pipetting error comes from operating technique. This was also demonstrated in a study that Artel did. They chose 475 trainees. These were from the pharmaceutical industry. And without much instruction, they just had them do 5 replicates of 20 microliters. And then you can see the graph on the left. This was the results. So on the y-axis, you have systemic error. This is this attributes to the pipette itself. So this has error in terms of accuracy of the pipette. What we want to concentrate on is the x-axis. This is in percent imprecision. So this directly is attributed to technique and errors in technique. Now you can see these 475 trainees were then given the chance to brush up on their technique. They were shown how to do it properly once again. And then they repeated the test, and the graph on the right shows you the result. You can see that in terms of random error, that was cleaned up significantly. Okay. Now, I start and open my talk talking about technique and this particular topic because it is so incredibly significant and important. As you all know, in some of your experiments, especially when you're doing a serial dilution, for example, right? Errors in pipetting technique can be compounded, which can have disastrous effects on your research results. And we've seen this. So Edwin has already been doing several trainings within the COWS community, and he's heard this from several individuals. Something to this effect where, hey, I've been pipetting for X number of years. I can't believe I've been doing it wrong this whole time. So the system is very valuable in allowing you to check your pipetting technique and precision, and gives you chances to brush up on that at your convenience. Now, coming back to the system, what I hope to do with this slide is assuage any concerns you might have in terms of the system reliability and accuracy. But to start, just know that this system can calibrate single channel pipettes from 0.1 microliters up to 5 milliliters. And with a little bit of training and experience, that can be done in less than 3 minutes. Now, the results are traceable to that's the National Institute of Standards and Technology in the US and the National Physical Laboratory in the UK using International System of Units. The system offers a digital review and approval workflow. I'll show a little bit about that in my training here in a minute. It does meet ISO standards, several ISO classifications. Probably one of the most important would be ISO 17025. This is a set of requirements that laboratories use to show, and equipment manufacturers have to show that they have a quality management system and competency in the technology. Now, the system does meet the US 21 CFR Part 11 standard. This is a standard that specifies requirements and standards for document and signature control. Now, we haven't configured the system to completely abide by this 21 CFR Part 11, but it is possible. And so if in the research community, if this is something that is important, then we can always reconfigure it to meet those standards. We have comprehensive reporting and audit trail capabilities, and the system does not require any special environmental controls. And this is due in large part because of its principle of operation. The system uses 2 dyes, one with a wavelength of 520 nanometers maximum, and the other is at 730. And it uses ratiometric absorption-based measurement. So essentially, one dye is used as an internal standard, the other dye is used as the reference, or the experimental. And what it does is it links absorption of that dye to concentration delivered. So it plugs it into Beer's law, where absorption is equal to the dye's molar absorptivity, the path length, and the concentration. From doing some simple calculations, it can deliver accurate results attributing concentration to absorption. Coming back to the system, I want to talk more about those reagent vials you see in front of you. So starting from the left, the calibrator. This is used to calibrate the system. Now, if you're the first one in, and I just reset this, you will the RTL through a calibration, very quick and easy. You through it, and so nothing really to memorize there. And then this is also done and performed after 8 continuous hours of use. Moving over to the blank, this is the vial that will actually go inside the unit, and you will add your volume data points from the reagents on the right to the blank in performing your calibration. Okay, so before we get to that though, I am going to demonstrate some of these techniques that were discussed in previous presentations. I need you to bear with me for just a moment while I turn the camera and get that set up. While I'm doing that, I would suggest that you go ahead and, in fact, let me come out of here, stop sharing. I suggest that you right click on my face and there's an option to do spotlighting that will bring up the broad video in your window to maximize it so you can see what I'm doing. Okay, bear with me, give me just one moment. Okay, so first I'm going to start off with how do you clean and do a user maintenance or inspect your pipette. So I suggest when starting with your cleaning of a pipette, you always take the volume all the way up to its nominal volume, or if you're using a variable volume pipette, making sure this is at its max volume, the nominal. That way we're going to expose the maximum part of the plunger so we can clean that. Always use a surface that is clean and inert, such as a stainless steel tray or an inert tray. For this demonstration, I'm going to use this large Kim wipe on this inert surface. You're going to want to use a disinfectant that is about 60% alcohol, is what's generally suggested. I hear a lot of beeps going on in the chat box, so let me just stop there and make sure. Can everyone hear me okay? And is the video clear on the pipette? Sally, can you let me know?
Hi, Jason. Yes, the video is clear and I'm managing the chat. So I'll let you know if there's a question for you.
Outstanding. Okay, so to continue, you can spray liberally your pipette alcohol solution, both sides, top and bottom. Okay, I'm going to take a lint-free Kim wipe and wipe down the pipette from top to bottom, all areas. What you're looking to do is making sure you're getting off any chemical residue, any corrosion. You're looking for any corrosive spots, making sure you get those off if you can. This looks pretty good. All right, once you've cleaned your pipette, if I put a lot on there, I'm gonna come through one more time, make sure that gets dry so it doesn't slip out of my hands. Okay. Once you've done that, you're going to want to inspect your pipette. I suggest that you start at the plunger, and some plungers are going to have a metal bar here. You're going to first make sure that everything's straight, that it doesn't look like there's any corrosion or chemical or physical damage on that. You're going to inspect the plunger, ensure that it has smooth motion all the way up and down, that it's not being restricted by anything there. All right, when you come to the first stop, you want to feel that there is a solid first stop, and then you can depress more, and it should be a higher pressure to depress to the next stop, and some pipettes will have even a third stop to check. You're going to want to make sure that the volume control selector moves freely, doesn't bind up in the numbers when you move them, right? Line up. Let me get back that. So I've lined it back up to the nominal volume. You're going to want to inspect the micrometer window. Make sure that it's clear. The numbers again line up straight. We're checking the body of the pipette, checking for any chemical or physical damage, any corrosion. This one looks really good. What I did notice in this pipette, that at the tip here, right, you can see, and Babu talked a little bit about that. You can see that there's some stress there at the tip. I'm not sure if you can see that in the video, but what I would want to do on a regular basis with an older pipette like this is perform a leak test, and we will be doing that here shortly. Now, when storing the pipette, I suggest that you always use, for me, I never like having a pipette anywhere on the table. You know, there's too much of a possibility of something getting spilled onto it, some chemicals, or just getting bumped off onto the ground, right, which can damage the pipette. Always use a proper pipette stand. And when you store your pipettes, you always want to do it at the nominal volume right? This takes pressure off of the springs and the internal mechanism of the pipette, right? Ensuring that we have a long life. Now, when using, so let's come to there. First, let's get a tip on this. So for pipette tip selection, you always want to make sure you're using a pipette tip that fits the pipette that you're using. Babu mentioned earlier, this is one of the pipettes where when you insert the tip, right, it has a bounce there or a reaction where it doesn't allow you to go past a certain force to insert that pipette tip. When using pipettes, I'm sure you all know, you never want to do this, especially if you have volume here in the pipette tip, right? Because then that volume can get into the nose, create contamination. I think that that's just a compromised pipette at that point, and you might want to discontinue use. So definitely make sure it goes through a comprehensive cleaning if that were to happen. But we're going to avoid that from happening because every time we're carrying our pipettes, even without volume in the bottom, we're always going to make sure that it's held vertical. Okay, now bear with me for one more moment. I am going to switch the camera again, come closer to the RTEL system. Here we'll demonstrate technique, do that's pre-wetting, how to properly aspirate, eject, and then we're also going to do our leak test. So just a moment. Okay. All right, probably what I should have done at the beginning, maybe I demonstrated what not to do, is I should have gloves on. So I'm putting my gloves on now to make sure we demonstrate that correctly, especially now that we're going to be pulling out the reagents. All right, what you should be able to see in your video there is the RTEL system and the computer. I'm also leaving myself some desktop space. I will be demonstrating the technique. Oh, these gloves are tight. All right. I'm also going to switch over and I'm going to share now the RTEL system, the software here. So you should now be seeing in your window, yep, there. Now in the small window, I'm going to leave that, that video on. So we'll use this view here in the small window for technique. I'm going to have the software in the background. Now, when coming up to the RTEL PCS, you can log on, get the software open. I should also mention, very important, I'm not covering this right now. There's a lot of details that are in the standard operating procedure that Edwin created and Saley sent out earlier. So you should all have that in your inbox. And if you like, you can follow along as I go through that procedure now. So when coming up to the RTEL, for advanced training, you'll talk to Edwin. He's going to teach you how to add a pipette into the system, how to then create a plan, a calibration plan for the system, a schedule, so on and so forth. I think that's beyond what I want to show you here. For the purposes of this demonstration, we're going to assume that I'm getting ready to do an experiment that's going to involve serial dilutions. And it's an experiment that's going to be, I'm going to make sure, I need to make sure that I'm using a pipette that is well calibrated and my technique is very good. So I've developed a plan for this pipette to be a verification at 20 microliters. So we'll use the pipette that I just cleaned. For the software, we just click on pipette. Scan that. And when you do that, it brings up some options here. So I can perform the scheduled calibration. I can view results from previous calibrations. I can edit the pipette. So what you could do here is you can edit the calibration, what type of calibration you're going to do, what schedule you're going to keep it on, so on and so forth, and some other options. So now I'm going to do a calibration. Put my pipette down. You can see here that this is the calibration schedule and the particular recipe that we have already loaded up. I'm going to hit start calibration. It's going to ask you which instrument to use. We only have one instrument right now, so I'm going to choose on that. It's already chosen. Hit OK. And it will take a minute. Sometimes it takes a little while. Now, in the software, you can see here, it says, please scan range 3 bottle. All right. When you come in, at least for now, we're going to talk more about how we're going to deal with reagents later. But next to the system, there's a set of drawers. You open up the top drawer, and it has reagent bottles 1 through 6. I'm going to choose reagent number 3. Make sure you can all see that. It's asking me to scan that. So I scan that. Oh, didn't read it. Let's try it again. Okay. Now it's doing dark readings. Do not open the lid. So it's going to run us through a calibration process. Now, in the drawer, you'll also find a set of disposable pipettes that we're going to use, as well as there should be some vials here for you to use as well. I'm going to show you what we need for those. But first, it's asking us to scan reagent calibration A, or Cal A. As soon as you open the drawer, you'll see it. Edwin did a great job in highlighting it. There's a special place for calibration A. Now with the calibrant, you do not take the cap off. Right? It's going to ask you to scan that. Let's do that. Oh wait, scan. There we go. We scan. Now it's going to ask you to insert it. I like to take a Kim wipe and wipe down the outside of that, make sure there's no fingerprints there, either my own or from someone previous. When you look at the vial, you can see that there's a little line in the front here. It's about 90 degrees off from where the barcode is. You're going to want to make sure that that line faces straight out towards you when you insert it. We're going to close the lid, and again, I showed you earlier that this piece here is you just touch that. That's how you open and close the lid. Now it's doing a 0-point check. When it does these checks, you'll hear some noise. Nothing wrong with the instrument. The vial actually sits on a small sonicator, or vortex, excuse me, and it's actually vortexing the solution before every reading to ensure that it's a homogeneous solution. We'll come back to the software now. It's saying, please remove vial. So we'll take that out. I'm returning it to the drawers. Now it's asking me to scan a blank vial. Also in the drawer will be several blank vials. You'll know the blank. Well, first of all, it says it very clearly on the vial, and it's going to be a blue solution. So I'm going to scan that. It's asking me to remove the cap. I'm going to wipe the outside with a Kim wipe and insert it. Close the lid. It's going to do its reading there for baseline. Now, it's getting ready for the actual experiment in data. To get ready for that, when you're using these reagents have a long life, about 9 months. That you don't cross-contaminate, you all know about this. I'm not going to be pulling my individual aliquots straight from here. I am going to use a fresh vial that's provided here at the system, and a plastic pipette, a disposable pipette, just to transfer some of this reagent to the vial. I'm going to recap reagent 3 and return that back to the drawer. All right, so now we have a reagent in this disposable vial. Now, here's where the work is done. So it's asking me we go back to the software. You can see in the top of the big letters, range 3, pipette sample number 1, and then close lid. So I just inserted a new pipette tip there. First thing you want to do with the new pipette tip is wet it. But you know what, before we do that, I did notice when I was doing the user maintenance that there seemed to be a little bit of stress on the tip of the actual pipette. So let's start with a leak test. To do that, I am going to insert. Well, first depress the plunger, insert, draw out my volume, and this is, and I kept it here at the nominal volume. So I always want to do a leak test at the nominal volume, and you guys can see that. So I'm going to hold this here for about 30 seconds. I'm looking to see if there's any drops that will come out of the pipette tip. You can see there's none, and so this would be a successful experiment. The leak test is good, it's not leaking. One other thing to know, that when you're holding the pipette, especially for a long time, I don't know if you can see that, I'm not grabbing the pipette like this and wrapping my fingers around it. I'm holding it loosely. That minimizes heat transfer from my body to the pipette, which of course can start heating up the pipette, which can then have it start acting a little bit differently and can affect the aliquots that are dispensed. So I'm going to return that back to my vial. So we've done the leak test. Now, the experiment is 20 microliters. So I'm going to adjust my pipette to 20 microliters. And 20. You guys confirm that. Now, proper technique. Some things that we learned in previous talks. All right, when inserting the tip, you want to insert straight into the middle. You always want to dip the tip only enough that to draw up the liquid you need, right? So if it's a very small amount of liquid, it's going to be about a millimeter. If you're drawing more liquid, like a mil to 5 mils, it's going to be several millimeters that you're going to want to put the tip in. Again, if you go in too far, especially if you hit the bottom, that's going to restrict the tip from being able to draw up the liquid. You're going to get an inaccurate result. Or if you're touching the sides, that's going to restrict. So when you come in, you always want to come in straight in the middle and just enough below the surface to draw up the volume you need. So I'm going to depress the plunger. When depressing, always use smooth motion and consistent pressure. When you go to the stop, you want to be consistent, because inconsistent pressure at the stop can also lead to inaccuracy in delivery. So depress, straight in. I'm going to release. I'm going to wait, let it, you got to wait there for just a second, pause, make sure it gives it time for that liquid to come back into the tip, straight out. When you deliver the sample, you're at a 30 to 45 degree angle. The tip touches the side. You deliver, second stop, straight up and out, close the lid, and the PCS will automatically start the run. Okay, you can see we delivered a volume of 20.63. The inaccuracy, we're about 0.6 microliters off. Our limit in this particular ISO calibration is going to be 2.4, so we're within range there. You'll notice that percent imprecision is 0 at this point, because of course you need 2 data points or more to measure imprecision. So let's go with our second data point. Straight out, close. Now, once you get this and your techniques down, you can go straight to drawing up your third data point while we wait for the instrument. I'm going to add that in. Close. I want to pause here for a second and see how we're doing. All right. Not too bad for an organic chemist, huh? Doing pretty good so far. We're at 0.5 on inaccuracy. We see our precision is 0.05 with a limit of 0.9. So I'm doing pretty good. Let's say, for example, I'm in a hurry and I go to depress and I go past the first stop. I draw up, and even as I'm coming out, I know, ooh, that was not a good grab. I want to deliver that. Let's see what happens here. So in this case, I went further past the first stop. And yeah, you can see that was definitely not a good run. At that point, what I can do is say, look, I know that I messed up there. Later on, we're going to come back to that, and we're going to redo that and record what happened. But let's go ahead and finish up. Do our fifth. In. Deliver. And again, you'll notice that it takes a little bit of time. You hear some noise. It's actually vortexing the solution, again, to make sure that we have a consistent, homogeneous solution. All right, so we've done our 5. Now, we were on a good track there, but that one data point really messed us up. And I know that my technique was horrible there. I just know going in that I had a problem. What I'm going to do is I'm going to redo that replicate. So you push redo replicate. I'm going to put in a comment. I want to always record what I did for tracing and for leave that audit trail. I know that I had bad technique. However you want to put that, you press too far on the plunger, okay, and then automatically the system's going to open up and wait for you to repeat that 5th data point. So let's go ahead and do that. Deliver and close. Okay, and there's our result. So you can see that the redo of point number 4 brought us back into an inaccuracy of 0.5. That was pretty consistent throughout. Imprecision is really low. That's good. Guess I haven't lost it after being out of research for a little while. If we are good with that, we can go ahead and hit finish. This then gives you the option to record the environment. Again, for just for ISO requirements, you want to record the environmental conditions when you did the experiment. I checked earlier, the room is at 21.5, relative humidity is 63%. There's a gauge on one of the walls here in this room, but don't need to worry so much about that. We have on order, and pretty soon LEM will be installing a gauge here on the back wall behind the system that will give you temperature, humidity, and barometric pressure, so you can read that directly off of the gauge when performing your calibrations. I'm going to select OK. Finish. At this point, it gives you the option to add another review or comment if you like. You can see here it says print label, so if this was a full-on calibration, you can check that box and it'll print out the label for you to attach to the pipette. I'm not going to do that for now. Hit OK. This should then take me to the report itself. It's loading. And here in the pipette calibration report, you can see on the left, it gives you all the information of the pipette, who's the owner, the location, and then on the right, it tells you the result of this experiment. It passed, when it was completed, so on and so forth. It tells you all the volumes and uncertainty, inaccuracy, tolerance, and precision, all those data points. And again, for ISO and also the CFR requirements, right? You leave nothing out. Everything that happens in that experiment gets recorded. You can see that when I had a bad point here, I was at number 4 that I did it, and my comment that I left is there to show anyone who might review this in the future. Okay, and as I'm doing that, I realize I messed up one thing. Who can tell me what I forgot to do in this demonstration? I'm looking at the chat box. There was one thing I should have done, and now that I'm thinking back, I did not do it. All right, won't leave you in suspense for too long. I did not pre-wet the pipette. I think Priya talked about that earlier. When you do a pre-wetting, let me just demonstrate that right now. What you want to do is, before your experiment, you always want to come up, draw up, and dispense. Do that about 3 times. Dispense. And what that's doing is, it's increasing the humidity or equalizing the humidity inside the tip and the cone of the pipette to ensure that your first volumes delivered will not be at more inaccuracy due to or as a result of evaporation into the pipette itself. Okay, now bear with me just a moment. I'm going to switch the camera back over to the desk. If there's any questions at this point, please be asking those in the chat box while I set up here for the remainder of this seminar. Okay, so we will stop share, come back around. Okay, a few last items that I want to talk about before I end my presentation. Some questions, I haven't been able to see the questions while I was up there. Some questions I can anticipate being asked is, what about data? So data transfer at this point, all the data will remain on the Artel PCS. George Klein, he's the lead, one of the leads of the lab equipment maintenance core lab team. He's working with IT right now to hopefully, the end goal is that we have a process where all the data is backed up on a properly maintained server. And we're hoping to have the option where you'll be able to download the software onto your computer, and then you can pull your data directly from your computer. Also, you want to repeat that the Artel can do single channel pipettes up to 5 milliliters in terms of calibration. For now, if you have a pipette that's greater than 5 millimeters in terms of its dispensing volume, those pipettes will still come to LEM, and we will do the maintenance and the calibration of those. If you have a multi-channel pipette, those will also come to LEM. Artel recently introduced a multi-channel pipette calibration system, and we're very happy with the results of this system, so we will be investing in that as well. So in the future, you'll be able to calibrate your own multi-channel pipettes as well. More to come on that, we'll keep you posted. I guess lastly, when it comes to consumables, to seed the system, LEM will provide consumables, probably last us for the next month or two. I don't want to commit to a specific date, but we think we have enough for a couple months at no charge to the community. So you're free and welcome to use these consumables. Once our initial stock is used up, we're introducing a procedure where you'll be able to purchase the consumables using the procurement catalog. And then we're in the supply room right now. That's where the system is. Kind of show you guys that. All right, so I'm sure most of you are familiar with the supply room. VWR is going to be inserting some type of a solution where it will dispense the consumables. The end goal there is hopefully having some system where you have a touchpad. You guys know with some of these other systems here, right? You scan with your ID. You already have a cost center loaded up into that. You retrieve your consumables. We're hoping to make that process as easy and worry-free as possible. I think with that, I have covered everything. At this point, I'm going to ask Saley, how are we doing with questions? Looks like we have 20 minutes scheduled for some additional question and answer time. We can continue to answer questions in the chat box. I also want to know, does anyone have a question they would like to ask? And if you do, I invite you again to raise your digital hand. So if you go into the participant window on the right-hand side, there's an option to click raise hand, and we'll call on you from there. Saley, how are we doing with questions?
Thanks a lot, Jason. Yes, I also have provided an option for participants to unmute and ask any questions if they have, once they raise their hand and we read out their name. I believe Amir has a few questions, and Michaela has also one question. Where can we find it and how can we book it? So, Michaela, if you can unmute your microphone and ask your question to Jason.
Hi, very nice presentation. Thank you. Yeah, I think you already show up where is the machine itself, but do we need to book it to use, or it's feel free?
That's a great question. I'm going to let Edwin come in here. He's the one who is in charge of the system, maintaining the system as part of the core labs. And I do know that part of the answer is we're working on eventually having the system attached to Badger or a similar system for booking and scheduling. But for now, Edwin, how are you arranging use of the instrument?
Hi, Jason. Yes, the way we are doing right now is we are receiving requests in the LEM system, just like another request, and then we can make a booking and schedule a training section with you and any other Pipette user that might be interested in try the system, create their accounts and being able to access. So once that is done, any user will be able to walk in and do their own verification and calibration of their pipettes at any time. So initially, the answer will be through LEM system, and you within your pipettes, we create all your accounts and give you access to the system.
Okay. Does that answer your question? Okay, any other questions? What I did while you guys are thinking, I reposted all of the experts we have from the Eppendorf team joining us. I want to thank them. We have Babu and Priya. Again, thank you guys for your presentations. We also have Shima, Akshay, as well as Amir. Thank you all for participating as well. Does anyone have any questions for any of this team or Edwin? Edwin happens to work with me on the LEM team. He's a member of the LEM team. Okay, I guess that was comprehensive. Okay, so Michaela says thank you. Thank you very much. Appreciate that comment. As stated before, we did record this event. We're going to clean it up, take out the breaks, and we'll be posting this recorded event. More on that. Definitely make sure you all get a message, an email, pointing you to the link where you can go to review the recording at your leisure. Looking at comments. Thank you very much. Yeah, can we have access to the presentation later? Yeah, I just addressed that, absolutely. Thanks for arranging this. Hopefully this will resolve the backlog issue with calibration. Yes, it's a good statement. I appreciate you bringing that up. Indeed, there has been an incredible backlog. And let me speak to that for just a moment. Not only has there been a backlog, and this has required more and more of LEM's resources to calibrate all of the pipette requests that we get. I always thought, look, this is a university. This is a teaching institution, right? It was a shame that we don't have a tool that allows you to assess your technique, right? As we've seen, there's lots of reports and data out there that, we all think that we might have the best technique. Heck, it's been a while since I've done this. When I was preparing for this, I thought I had great technique. My first run on this, you don't want to see the results. It wasn't pretty, right? So I fell into that as well. So this gives you the option now and the opportunity to test your technique and brush up on your technique at your convenience. Okay. All right. I don't see any other questions. I think we addressed them all. We'll end it there then. Thank you all for your participation. Again, thank you to those from Eppendorf for joining us. Again, a very big thank you to VWR of Antwerp. This would not have been possible without all of your work, help, aligning this up, coordinating it all in the background. Thank you very much.